Assalamualaikum warahmatullahi wabarakatuh. Today we will present linear algebra 2. We are from CDCS 2493A. This video was prepared for Madam Maziah binti Mahmud.
Hi and Assalamualaikum. My name is ILLI SYAFIQAH binti ABDUL RAZAK. My student ID is 2023680518.
Hi, Assalamualaikum. My name is ERNI NADIRAH binti Muhammad SUFIAN. My student number is 2024629592.
Hi and Assalamualaikum. My name is SITI KHADIJAH binti KHALIL. My student number is 2024430118.
This study was carried out to observe relationship between household level income and expenditure in Sarawak. This data was taken from Malaysia Official Open Data Portal. These data were based on household income and expenditure survey carried out in 2022. The survey is conducted twice a year over a rolling 5-year period in order to gather representative data on household income, poverty, and access to necessities in Malaysia. So, this is the data. We take mean income and mean expenditure, and we take 20 streets in Sarawak, which is Kuching, Bau, Lundu, Samarahan, Serian, Simunjan, Sri Aman, Lubuk Antu, Betong, Saratok, Sarikei, Maradong, Daro, Julau, Sibu, Dalat, Mukah, Kanawit, Song, and Tatau. So, based on the data given, we determine the independent variable X is mean income and the dependent variable Y is mean expenditure.
Firstly, we convert the data into the form of system of linear equation by using the linear formula ax plus b equal to y. Below are the equations for the data.
The metric representation of the previous system is MV equal to 1.
Metric form equations. We let n transpose m times with v equal to m transpose times with y.
The least square, we let V equal to M transpose M inverse times with M transpose Y. So as you can see, this is the best fit linear equation curve. This is error vector. We let the equation with Y minus MV equal to E. So this is magnitude of error.
Firstly, we convert the data into the form of system of quadratic equation by using the quadratic formula, which is ax squared plus bx plus c equal to y. To convert the data, we must find the value x squared for each data and substitute into the formula. Next, we create the metric representation of the previous system, and then we let MV equal to Y. So this is metric form equation for quadratic equation. We let M transpose multiply MV equal to M transpose multiply Y. Next, we calculate the least square solution. We let V equal to M transpose M inverse multiply M transpose Y. After we calculate the least square solution, we will get the best fit quadratic curve. So this is the fit quadratic curve. Next, we calculate error vector. We let Y minus MV equal to E. Lastly, we calculate magnitude of error. And this is our answer for magnitude of error for quadratic equation.
First, we convert the data into the form of system of quadratic equation by using the quadratic formula, which is ax cubed plus bx squared plus cx plus d is equal to y. To convert the data, we must find the value of x cubed and x squared for each data and substitute into the formula. Below are the quadratic equations. The metric representation of the previous system is mv is equal to y. Next, we form the equation of m transpose times m times with v is equal to m transpose times with y. To find the least square solution, we must find v, which is equal to m transpose times m inverse times with m transpose times y. And we get the best fit quadratic curve, which is y is equal to, and then we find the error vector, which is n minus mv is equal to e. To find the magnitude of error, we need to substitute the values into this formula.
This is a graph for linear equation, which is I got straight line for this equation. This is a scatter plot for linear equation. Lastly, this the graph when I displayed 2 of 10 in one graph.
So this is our graph for quadratic equation. We can see for quadratic equation, we get the curve graph, and for the scalar, we use a equal to negative 3000 and 3000. This is our scatter plot for quadratic equation. So this is our graph for quadratic equation when we combine for curve graph and scatter plot.
This is the graph of cubic equation. Next, we put x and y value to plot the graph. And this is the scatter plot of the graph of cubic equation. And then this is the plot of scatter plot with cubic equation.
Next, this analysis of magnitude of error for 3 equations, which is linear, quadratic, and cubic equations.
This study analyzed household income and expenditure data from Sarawak using linear, quadratic, and cubic models to determine the best fit curve. The quadratic model showed the lowest error magnitude among the 3 models, which is suggesting that it offers the most accurate approximation for the data. Additionally, graphical analysis verified that the quadratic curve best fits the data points. This finding highlights how well the quadratic model captures the connection between income and expenses in the dataset. This study has successfully found trends and patterns in household economic behavior by using mathematical modeling tools, providing insightful information for future research or policy development. Thank you so much for watching.